Okay, so let's go to number 11. Don't worry too much about that. Now, this says number 12 on this one, but it's 11 for you. This is important because when it says it's the net signed area, it's important that you realize that an integral treats the area underneath the x-axis as negative. Okay, so let's just do this for now. Okay, and again, we're going to be learning different ways to do this very soon. But for now, what I would want you to do is go through and figure out what we would get for this integral. So if we were integrating this with our new notation, we would say we're going from 0, our lower bound, to 18. This is 18, and this is 0. That's our upper bound. Okay? And we're going to take our yellow and then we will subtract the red. Because the yellow we would add up as positive areas, and then we would then subtract the red. Now, you can't have a negative area. It's just that the integral treats the area as a negative region. And it's important that if they ever switch, see how your lower bound is smaller than your upper bound? If they ever switch that and they were to write it like 18 to 0, then what happens then is you end up getting the opposite of your integration. So if I did that, I would have like the opposite of my piece out here. So there's an example of this later that we can get into. All right, so let's do some more work with this with actual numbers. This was just a little picture to show you positive and negative. Okay, so it says sketch the region whose signed area is represented by the definite integral and evaluate the integral using the appropriate formula from geometry. So we're not using anything crazy. That means if we're going through and we have a triangle, we'll use 1/2 base times height. If it's a rectangle, we'll use length times width, and so on. Okay, so they're saying look from 0 to 3, absolute value of x minus 2. Hopefully everyone in here knows that this is a v, and it has been shifted to the right 2 places. So come to your graph over here, please, and let's put a 2. Okay, if you sub 2 into this function, you'll get 0, so we have a point right there. If you sub 1 into our function, 1 minus 2 is -1, but the absolute value of -1 is +1. And if we sub in 0, we'll get +2. Okay, over here, if I sub a 3 in to my function, I will get 1. And if I sub a 4 into my function, I will get 2. Now, since they only want me to go from 0 to 3, that value is not necessary. Okay, so I'm just going to go through. Let me sketch that V graph. Okay, and I'll use a different color to talk about the region they want. So they want me to go from 0 to 3. So let's color in the area under the curve from 0 to 3. Okay, and then we're going to go through, and they want us to find the net signed area. So we have 2 triangles, so area equals 1/2 the base times the height. That's the area of a triangle. So triangle number 1, we would have 1/2. The base is 2. The height is 2. And then we have the second triangle, 1/2. The base would be 1, and the height would be 1. Then we just go through, and let's see, that's 2 plus 1/2. So I'm getting 5/2 for the net signed area. Okay, notice both of these were above the x-axis, so both of my highlighted area is going to be positive. Okay, when you're finished with that, turn to the next example. Okay. So again, we're doing the same thing. We just want to go through and figure out what is our graph going to look like. So side note, do you know that the area or the equation of a circle is equal to this. Let's add this to your notes. Okay, this is the equation of a circle. And the H and the K are the center points of your circle. So if I were to just play with this and put some values in here. Okay, this would be a circle with the center of 9, 6, with a radius of 10. Okay, so that's just side notes, because now if you're looking at this problem and we have y equals the square root of 4 minus x squared. If I square both sides, I get y squared equals 4 minus x squared. And I can add x squared to both sides, getting me x squared plus y squared equals 4. Okay, x squared plus y squared equals 4. So what does that tell me? Well, it tells me that this equation that I'm looking at is a circle of center what? 0, 0, with a radius of 2. Okay, so when I go to draw this picture, I have a center at 0, and I have a radius of 2. Okay, so let's just say that I'm looking at that circle. Now, with this problem, if they only want me to go from 0 to 2, what would I draw here? Well, oh, and on top of that, I don't have the whole circle because this right here doesn't have a plus or a minus, so I actually have the top half of this circle. So let me just sketch that in first. Okay, and I'm really only going from 0 to 2, so I'm looking at this. That's the picture that we are finding the area under that curve. Okay, so with that being said, what is the area of a circle? Well, the area of a circle is pi r squared. Okay, and this is not a full circle. This is a fourth of a circle. So I'm going to put that over 4. So looking at my problem, the area of this region would simply be pi times the radius of 2 squared over 4, which gets me what? Pi. Okay, and again, I'm sorry, I didn't realize that was not clearly showing, but you can see it there. Okay. And again, this is only the top half of the circle because when I had my equation y equals the square root of 4 minus x squared, it wasn't plus or minus, so it never gets me that that negative region. Okay, all right, let's go to the next example. Okay, we have to add a picture for this problem. For me, for this board. So what I would like you to do while I go through and draw this is please start to go through and drop in some lines to break up this crazy shape that I've given you into some rectangles and squares and triangles, and just start to go through, please, and find the area of each individual piece, because then we're going to add them up together.